So it's page 638, problem 22, -5 and 0 degree. So first let's get r, -5, and theta equal to 0 degrees. And we need to find x and y coordinate of this point. So we know we have the formula here. So x is equal to r times cosine theta, and y is equal to r times sin theta, right? So now we have the x equal to r times cosine theta, and this is equal to -5 times cosine of the 0 degrees, and this is equal to -5. And then y is equal to r times sin theta, and this is equal to -5 times sine of the 0 degrees. We know sine of the 0 degrees is equal to 0. So this guy is equal to 0. So now we just convert from this polar coordinates to this rectangular coordinates. Okay, so this is the first example. We do this conversion. Now let's look at another example, 25. And this time we have the 1 and the pi over 6. So r in this problem is equal to 1, and theta is equal to pi over 6. So we need to find the x and y coordinates of this point. So by the formula, x is equal to r times cosine theta. So it's the 1 times cosine of the pi over 6, and this is equal to root of 3 over 2. And then y is equal to r times sin theta, and this is equal to 1 times sine of the pi over 6. So this is equal to 1/2. And then you get the rectangular coordinates of this point. So we finish this conversion from 1 and pi over 6 to this square root of 3 over 2 and 1/2. Now let's look at the problem 36. And this time we need to convert this rectangular coordinates to the polar coordinates. So use the degrees for the theta. So it's the page 638 and the problem 36. We have the rectangular coordinates -2 and 2 times root of 3. So that means we have the x equal to -2 and y equal to 2 times root of 3. And let's first find r. R is equal to the square root of x squared plus y squared. So this is the square root of the square of -2 plus the square of 2 times root of 3. And the first term, this is equal to 4. Second term, square of 2, 4. And square of the root of 3, 3. 3 times 4, you have the 12. So you have the square root of the 16. So that is equal to 4. All right. So now we find r. Then let's get the tangent inverse of y over x. We try to find the angle theta. And let's first find this, okay, tangent inverse of the y over x. So it's tangent inverse of the 2 times root of 3 over negative 2. So this is tangent inverse of negative root of 3. What is angle for this tangent inverse of the negative root of 3? We know inverse tangent of root of 3 is equal to 60 degrees, right? So this guy should be equal to negative 60 degrees. So now, when you convert the rectangular coordinates to the polar coordinates, you need to plot this point in the rectangular plane to determine the position of this point, to see which quadrant this point is in. So now let's plot this point. So actually, negative 2 and 2 times root of 3, so it's about here. Okay, so this is the negative 2 and 2 times root of 3. So it's in the quadrant 2, right? And by this formula, we know if the point is in the quadrant 2 or quadrant 3, then you need to add pi to this, okay, tangent inverse of the y over x, right? So now theta now should be equal to 180 degrees, which is same as pi, plus this tangent inverse of y over x. We do so because we always take r to be a positive number when we convert from the rectangular coordinates to the polar coordinates. So now this is 180 degrees minus 60 degrees, and it's equal to 120 degrees. So actually, this angle is equal to 120 degrees. And then you get the polar coordinates of this point. So r is equal to 4. So let's first write the rectangular coordinates. Then we convert this from the rectangular coordinates to polar coordinates, 4 and 120 degrees. Make sure when you convert from the rectangular coordinate system to the polar coordinate system, you plot the point in this rectangular plane and determine which quadrant this point is in. If the point is in the quadrant 2 or quadrant 3, then you need to add the pi to this tangent inverse of the y over x to get theta. But if the point is in the quadrant 1 or quadrant 4, then you may just directly use this tangent inverse of the y over x as the value of the theta. Now let's see how we graph a polar equation. Okay, let's look at a simple one. And suppose we have such a polar equation, r is equal to 2 times cosine theta. And to plot this polar equation, as in the rectangular coordinate system, we take some values for the input theta, and then find the corresponding values for the r, and then we form the order pairs. Then we plot these chosen points in the polar coordinate system, and then we use some smooth curves to connect them to get the graph of this equation. So let's first take some values for theta.